Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Okay, before we have 5 more minutes. Anybody who has some problem or question, okay, regarding the homework problems that I give you. You know, we have 5 minutes. If you want to ask me or discuss any question, we can do it now. Anybody? No question at all? Oh, okay. No question. That's good. Yeah. I was adjusting something. Okay. Anything? No. Okay. So if there is nothing, I will continue. Actually, we have four more minutes. You know, our class is start at 10. No, 9:56. 7. So if you have anything, okay, to discuss or anything that you want to make comment or homework questions, we can do it now. Hurry up, 3 more minutes. Okay, if you have no question, I will continue. Okay, we'll continue from where we left last class. That is on the concept of inequality. So what I will do, okay, I will look at the general form of the function or the inequality. And then we will draw the inequality. Using the slope-intercept form is not that straightforward. So we use the general form, okay, which is, to me, easier. So let's consider another example, and that example, we will look at the general form of the inequality. So let's look at example number 2. Okay, example 1 we already have. So this is example number 2. Okay, I would like to look back, our first example. You have okay, let's consider the following. Let's say I have 2x plus 3y. Last time we have less than or bigger than. Yang semalam tu bigger than. Okay, we try something less than. Okay, less than equal to 25, 24, 24, 20, 27. Okay, let's make it 27. All right. So I want to draw this inequality. So what do we do? First, all right, we consider the corresponding equation. So we start with the equation. We have 2x plus 3y equal 27. Okay, now let's do this quickly. What is the x-intercept? You want to find the intercepts. Okay, what is the x-intercept? Yeah.
X-intercept.
X-intercept, y equal to 0. So what is x?
Jap. 27/14.
13.5.
27 over 2, right? 27 over 2, 13.5. Is that right? So that point is 13.50. Betul? Okay, next, y-intercept. Y-intercept means x equal to 0. What is y?
9.
Y is 9. So you got the point 0, 9. So these are the points 35, 0, 0, 9, the intercepts. Now we'll draw the graph. Okay, so let me just draw on the same graph. Oh, I think we go too we go too fast. We need to finish up the the first example. Okay, so let break. Yeah, okay, put a break on that thing. We finish up this one. Okay, we haven't finished this. So actually this equality, I write it in general form. So we go back to the first one because I need to finish up this one. We already done with that thing. So that is the general form. Okay, we already drew the corresponding equation. Now we want to find the inequality. What are the points that satisfy the inequality? Okay, so we already know that the points on the equation. So number one, there are two parts here. The equal sign. So this is bigger than or equal to. Y minus 5x equal to 24. So we know all the points on the line. Okay, all the points on the line will satisfy that equation. So number two, you're going to find out what are the points that satisfy y minus 5x bigger than 24. So that is our second part. So what we were doing last time is that we take the point berapa itu? 55. All right. So take a point 55. You test that point. 5. We substitute. Okay. Substitute. What do we get? We get 5 minus 5 times 5. That is equal to negative 20. Okay, so you have to compare with the term on the right hand side. Now, is negative 20 bigger than 24? Negative 20 is not bigger than 24. So that sign, okay, the straight line indicate not. Okay, it's not bigger than 24. In fact, negative 20 is less than 24. So does not satisfy. Okay. So does not satisfy. So therefore, that point 55 does not satisfy. All right. So this point 55 does not satisfy. So we already determined. Okay. So if that point does not satisfy, our theory says, then all the points, okay, all the points on the same side of that 55 will not satisfy. Okay. So we say that the point 55 does not satisfy. That means, okay, all the points on the same side as 55 all the points on the same side as 5, from off the line, okay, off the line, do not satisfy. So we need to only test one point. So all the points on the same side as the test point, of the equation will not satisfy. So therefore, what is our conclusion? What is the answer? So therefore, what? Therefore, you test. What point do we need to test? Which point? Now, all the points on the same side as 5, is already out because it will not satisfy. So which point do we need to test now? You need to test what point? The point, on
the left side.
On the left side.
At the left side of
Okay,
graph.
so we take one point. As we did earlier, we choose negative 10, 20. So what we do, we come back to this one afterwards, all right? So that will be the second test point. Okay, our test point is negative 10, 20, negative 10, 20. Okay, so again here we substitute equation 3, 5 minus y minus 5x, y minus 5x. So y minus 5x, that would be 20 minus 5, negative 10. So here you got 20 plus 40, all right? And that is, of course, bigger than 24. So that point, 10, 20, satisfy the inequality. So, therefore, all right, all the points, okay, all the points on the same side as 10, 20, okay, to the line, will satisfy. All right. So what is our inequality? What are the points that satisfy that inequality? Will be the points, all the points on the same side as negative 10, 20. So those are the points. And there are so many points. In fact, there are infinitely many points. So therefore, what we do, we shade the region. All right. So to show the inequality, we will just show it by shading the area. So therefore, these are the points. Okay, the points on the same side, these are the points. So shade it nicely. Okay, shade it nicely. So that will be the area of the inequality. So that will be y minus 5x bigger or equal to 24. And we already taken care of the points on the line. All right. Okay. So what can we deduce from here? What we can deduce from here? Now, what we deduce from here is this. We took the first point, 5, 5. Right? Now, when you took the first point, 5, 5, and that point does not satisfy, all right? That point 5, 5 does not satisfy. Do we need to test another point the other side? That's my question. Do we need to test another point on the other side?
No.
What do you think?
No.
Oh, you don't have to. Okay? If you want, of course you can, but you don't have to. So you know, all right? So our other deduction is this. Since our test point, we go back to the first test point, all right? Our test point 5, 5, that does not satisfy. And we know, okay, all the points on the same side S55 will not satisfy. So therefore, you don't have to test another point on the other side, which is what we did was negative 1020. We don't have to. So we just conclude. Therefore, all the points on the other side will satisfy. Okay? So you don't have to test a point on the other side. All the points on the other side will satisfy. So we need to only take one test point, okay? Only take one test point. So we make our conclusion. If that point satisfies, then all the points on the same side will satisfy. If that point does not satisfy, then what happens? Then all the points the other side will satisfy. Okay, correct? So you need only one test point. Doesn't matter, you know, the test point satisfy or do not satisfy, we can still make our conclusion without taking another point. Okay, any question about that? Okay, good. So let's do the second example. Now, our second example, we already have the equation. 2x plus 3y equal to 27, and the intercepts are 13.50 and 0.9. Okay, by the way, are you done with this thing here? Are you finished? I want you to understand, all right? So if you want to write, I'll give you time to write. Are you finished? Are you finished with this page?
Yes, sir.
Finished? Okay.
Yes.
So let's draw the graph. Okay, we have the intercepts already. I want you to draw the graph, the equation, the second example, on the same graph as our first example. So don't draw another graph, just use the same graph. So you can, you know, we use the same interval. And we draw that line. Okay, everybody got it? So the intercepts are 0.9, 13.50. Okay, everybody got the line? So I want you to go back to the graph and put that thing here. Okay, use the same graph. So what I'll do, I will clean up this thing. Because I need to draw another graph. Okay, you got the lines? You got the line? First point, the x-intercept. What was the x-intercept? X-intercept apa tadi?
13.50.
90 ke tadi? I forgot. 90 ke 7.50?
13.50.
Okay, that is the x-intercept. So 13.50 be somewhere here. All right. Now, what is the y-intercept? 90, 09, yeah? 09. Okay, 09 will be there. So you got the line, all right? We connect the line, that would be the equation. Oh, I missed that point, but that's okay. So it should be here. So that is the equation 2x plus 3y equal to 27. Now, you take a test point. All right. Now, doesn't matter test point. What point do you choose? You know, it doesn't matter. We just only take test point 1, and then we conclude as per our discussion earlier. Okay, give me one test point.
5.
Huh?
10.
Berapa?
5.
5 again. Another point lah. 5 tadi dah buat. 5. Give me another point.
8.
10.
10.
You can do 10. Okay. Okay. You do 10, and see whether does it satisfy or not. Okay. Now I give you a simple point. Now when you do this test point, you want to make sure, or not you want to make sure. No, you want to be efficient. Okay. So you want to take the simplest point. Okay, simplest point. So that when you compute, you will compute the smallest number possible. All right. Now, what is the simplest point in the graph? Is there any simpler point than 10? 10, you have to substitute 10. You know, you multiply, you get
0,
the sum.
0.
So the simplest test point is what? 0, 0.
0, 0.
So anytime you have an inequality, you do the simplest point, you test with 0, 0. You test with 0, 0, you get 0. Okay? And then you get 0, you compare to the term on the right-hand side, whether it is bigger than or less than, which is determined by the inequality, then you have the solution. Okay? So test with that point, 0, 0. So you will get a simplest possible number. So if you do it, then what you get? You get 0, 0. Okay? No, you get 0, 0. You get 0. So you test with that point 0. You got 0. Now, is 0 less than 27? 0 is less than 27.
Yes.
So that point satisfied. Okay? So we do that. So continue from here, from there. So test point 0, 0. So what you got is 2, 0 plus 3, 0 equal to 0. And 0 is less than 27. So therefore, 0, 0 satisfy. Okay? When 0, 0 satisfy, that means all the points, okay? All points on the same side as 0, 0 from the line will satisfy. So it is quite straightforward. So you go back to the graph. This point 0, 0 satisfy. Therefore, all the points on the same line, on the same side as 0, 0 will do satisfy. So this is the points for that inequality. All right. So shape that. So I have 2x plus 3y less or equal to 27. So that would be our inequality. Okay. All right. Good. So what I would like you to do, okay, I want you to do one example, okay, for your practice. So go to the book. All right, go to the book. I will give you one question to do. Ya, mana ada soalan? I'll give you one question. I am going to choose one question. Okay. Do this one. Mana dia saya punya pen? Oh, no. Okay. Example 3. We have 5x minus 2y bigger or equal to 102. 104. Okay, 104. Okay, I want you to draw that inequality. Okay, do it now. I'll give you a few minutes. Oh, if you don't mute your mic, ada ni ke? Ada bunyi kacau ke? Okay, who is this N? I told you, put your real name. Like I'm Haman Akmal Hazik. So this N, okay, who are you? This is not the N, no Nabila. So don't put that N, okay? Put your name, just like the others. And this is another N. So this one is more difficult for me to see, okay? I don't know who are you? NSAJML, apa benda ni? Itu lebih betul nama lah. Okay, no Nabila. So you write your name as other people. Okay, this N, are you here? So please take note, okay? It's easy, it's difficult for me to check your attendance. Your name as in the list is not. It's not NSAJML. Okay? So susah sangat ke? I already remind you, put your real name. Susah sangat ke nak faham? Simple je benda tu. This kind of thing, I don't have to say a few times. I say once. Because I want to check your name, to the list that you register on. So on that list, it doesn't give you just M, it give you your full name. So I told you, put your real name, like other people here, Noliana and all this. Don't put your short term apa benda. Okay. All right. You got the intercepts. Soalnya diam. Aku ada kelas. Diam. Nanti kau dia datang. Okay. Number one, okay, we consider the equation. What is the equation? The equation is 5x minus 2y equal to 104. Right? Now, what are the intercepts? Anybody got that intercepts? Give me the x-intercept. What do you get?
20.80.
20 point apa? 20.80. Okay. So make sure you show how to get it. Okay. I do it this way so that we can save some time. Then the y-intercept 0.52. Okay, that one is easy to get. So you draw the line, I think I will use another graph because that graph is already loaded with, with all the sheets. So we draw another graph. So I will do it here. No, I think I will do it. I'll do a good graph. So those points are 20, 50. So we can use again here, 10, interval of 10. Or if you want to save space, you can use interval of 20. Right? So let me draw the graph. Kita use I use 10. Okay? 10, 20, 30, 50. So that is X. That's why we use 10, 20, 30, 50. And put some negative value, negative 10, negative 10. So I think my negative interval is small. It doesn't.
Bening.
Huh? Pening apa pening pula? Okay.
Sorry,
this is
sir.
negative 10.
Sir,
Yeah.
the y-intercept is 0 and negative 52.
Yes.
Tadi tak ada siapa yang cakap. So negative 52 eh?
Yes.
Okay. Nobody tell me when we say 52, you keep quiet. So 52. So thank you very much. Okay. Next time, if there is a mistake, make the correction. All right. I think when I make a mistake, at least 1% no. Okay. But sometimes you choose to be quiet. So if you choose to be quiet, then you are misleading all others. Okay. So make sure if you know there is a mistake, let me know. All right. Yeah, that one I thought it was 52, and everybody say yes. So negative 52. So negative 52 for that y. So I need to redraw my graph. So I don't have enough space for the negative. So we need more space on the negative side. So okay, that is that's X, that's Y. So I make a negative for the Y. I make 20. All right. So this is 20, negative 20, negative 40, negative 60. So that is 20, 40. Now for the X, let me see. X, can we use 20 or we use 10? For the X, probably we can use 10, all right? So we use 10 for the X, so it's 10, 20, 30. And here is negative 10. So we begin with the points, the x-intercepts and the y-intercept. You have 20.80. So 20.80, the intercept will be here. And then for the y-intercept, you have negative 52. Is that right? 52 already? Negative 52. So 50 is somewhere in the middle, so a little bit there. So that is, those are the intercepts. You connect the line, and we got the equation. Betul, 52, okay, 52. So you got the line, you draw it like that, and this is 5x minus 3. 5x minus 2y bigger or equal to 104. So 5x minus 2y bigger or equal to 104. 104. Okay. So you take a point 0, 0. Okay. Now, as you can see, 0, 0 will not satisfy. I want you to work it out. That will be equal to 0. And 0 is not bigger than 104. In fact, 0 is less than 124. So therefore, where are the points? The points that satisfy the inequality will be the point the other side of 0, 0. That will be here. Okay, everybody got the correct inequality? I mean the correct region. So you got 5x minus 2y bigger or equal to 104.
Yes.
Okay, good. So
Yes.
make sure, you test with 0, 0. So we cannot conclude, all right? You cannot conclude bigger, that means must be on the top of the line, okay? It is not necessary. It depends on the equation. So what you do, you have to look at the test point. So just 0, 0, okay? All right. So I think that will conclude our discussion on the concept of inequality. Oh yeah, one more thing. Another possibility of inequality is what I say earlier, strict inequality. Okay, when you have a strict inequality, that means we only have bigger than or less than. All right. Example, we go back to the example that we had. Suppose we have only 5x minus 2y bigger than 104. So example, 5x minus 2y bigger than 104 without the equal sign. Now, how do we get that inequality? The method is the same. Number one, you get the corresponding equation, okay, which is 5x minus 2y equal to 104. And then you proceed as what we were doing earlier. Take a test point, all right, and then you get the inequality, get the region, okay, get the points that satisfy the inequality. So in other words, get the region, okay. So method is the same. The only difference will be number 3. Okay, the starting will be the same as what you have earlier. Now, with bigger than, that will exclude equal to. Okay, exclude the one that has the equal to. Now, what are the points for which you have 5x plus 2y equal to 104? What are the points?
The points that on the line of the
The
equation.
points on the line, okay? So that simple thing will exclude the equal to, that means the equation. That means we'll exclude the points on the line. The equation doesn't hold, okay? Because you don't have the equal sign. You have only bigger. So therefore, how we show it? We show it by broken line. So if I do it here, okay, we show it by broken line. So when you draw the line, you make it break at some regular intervals. So that will indicate strict inequality. So that will, okay, that means, okay, with the breaking point, with the breaking lines, that is 5x minus 2y bigger than 104. All right. So that does not, okay, that exclude the points on the line. So how do you show it? Show it by broken line. But that will be done after you get, after you get the equation, after you get inequality, that you can do it. Okay, or when you draw the graph of the equation, you draw it by using the breaking line, the break line. So it's bigger than, and that is also true for less than. Okay, so if you have just less than, that means we'll exclude the equation. In other words, that would exclude the points on the line. You show it by the breaking line. Okay, you break the line. All right, so that's how we do it. Okay, I'll give you some question in the book. I would like you to do these questions. Go to 4.1. Do number berapa ya? Number 9. Then you do number 10. Now, if you look at these questions, they already give you the curve, the line. All right. Now, I want you to draw the line. Okay, get the intercepts. Of course, those lines are good, so that make sure that you will guide us. So treat the line as your guide. I want you to do the steps. Okay, all the steps. So 9, 10, 11. And then do number 16, 17, 18, up to 18. I think that we know. Okay, I think that's good enough. If you look at the book, okay, if you look at the book, all the questions, they include another constraint, which is x bigger or equal to 0, y bigger or equal to 0. So this will correspond to our equation. Okay, one of them is the function, the other is not, but correspond to equation x equal to 0. And this one corresponds to equation y equal to 0. So where is the line x equal to 0? Is it the y-axis or is it the x-axis? And what is the line for y equal to 0? So you go back to the graph here. Okay, where is the x equal to 0? Vertical line, horizontal line?
Y-axis.
Is the y-axis. Okay? X equal to 0 is the y-axis. Because it's easy to see, okay? On the y-axis, you have the y-intercept. So you got 0, 0. You got 0, 20. 0, negative 20. So here, all the x are 0. So that's why you call it x equal to 0. So x equal to 0 is the vertical line. Yeah. Correct? So that is x equal to 0. So when x bigger or equal to 0, that means it will be all the points on your right hand side. Okay, that one. Now, what is y equal to 0? Y equal to 0 is what? Is the horizontal axis.
Horizontal.
Okay, it's easy to see because all those points on the x-axis or x-intercepts, that means everywhere y is equal to 0. So that is y equal to 0. Now y bigger or equal to 0, that will be all the points above that line. So if you include, all right, if you include these two inequalities, x bigger or equal to 0, y bigger or equal to 0, where is our, oh yeah, that is different. That is regarding a system. But So this is x bigger equal to 0, y bigger to 0. I want you to recognize, okay,
Just
the point.
quadrant only.
So for the questions that I want you to do, you don't have to include that thing. Okay, for these questions for now, all right? We need to know what are these. But for all these questions, this x bigger equal to 0, y bigger equal to 0, tak payah fikir. Okay, don't consider. You just look at the proper inequalities. Okay, the x equal to 0 by y bigger equal to 0 to, for now, don't worry about it. Okay, we will worry about it later on. For now, okay, we just need to know where is that inequality. So make sure you know, x equal to 0 is the y-axis. Y equal to 0 is the x-axis. So we are done with the concept of inequality. All right, any question, any comment? Okay, this is good. I mean, we are moving at a good speed. Okay, now what I want to do next, we want to look at a system of inequality. Okay, system of inequalities. So just like a system of equations, you have two or more inequalities. And then when you have two or more inequalities at the same time, simultaneously, then you want to find the solution. All right. Now, what is the solution to the system? The solution to the system, all right, can be, number one point. This is very, very, very rare, very rare it happen. It can be many points. Okay, it can be many points. And many points, it can be, we can identify it as an area. There are many points, it's an area, or we can call it region, or the term that we use normally is the feasible region. Okay, feasible region, or we say common area. Or number three, there will be no solution. No, that means there is no point that satisfies the system of inequality. So we are interested in doing this one. Okay, many points. If there is no solution, then you cannot find the solution. And we do this by, of course, by using the graphical method. So it's just by observation, okay? You draw the graph, you observe, and then identify. Okay, identify, and then you make the conclusion. Okay, then we conclude. So how do we identify the points that will be the solution? So specifically, that will be number 2. Okay. Now that solution, we will do it by observing the common area. Okay, I already stated that, common area. What do you mean by common area? It's the intersection area. Okay, intersection points or intersection area, because there are many points. So it is an area. So intersection area, that means the area or the region that satisfy, that is satisfied, or that satisfy the region or the area that satisfy all the inequalities. Okay, inequalities in the system. Okay, so the area, that means the common area, intersection area, that is the area that satisfies all the common, or not the common, that satisfy all the inequalities in the system. All right, so that is our solution. So the solution to the system is a common area. And that area is the intersection of all the inequalities. If there is a solution, you know, if there is no solution, that means there is no common area. There is no intersection between the inequalities. So in order to get a better understanding, look at an example. So go back to the graph that I have earlier. I have 5x minus 2y bigger or equal to 104. That would be that. I think we draw another graph. Maybe we use the first example. No, this one we can do. Okay, so we go back to our first example. Then what you have is these two inequalities will be a system of inequalities. So you have a system of two inequalities. What are they? Number one, you have, okay, write down the system. Okay, what is it? I have 2x plus 3y less or equal to 27. And what is the other one? The other one is negative 5x plus y bigger or equal to 24. So that is our system. So our system as per inequalities in the first example and the second example. So that we can easily identify the solution. Okay, so let's do that. So the example that we have is a system of two inequalities. Number one, I have 2x plus 3y less or equal to 27. And then we have negative 5x plus y bigger than 24. So that is a system, all right? So what we do here, you want to find the solution. So step number one is what we have been doing, okay? Step number one, we draw all, okay? All the inequalities on the same graph. Okay, you draw inequality in the same graph, which we know how to do it. So firstly, we draw, okay? We'll draw this one, and then we draw that one on the same graph. Okay? Number two, of course, when you draw, you shade the region, okay? Make sure you shade the region. And then you identify, okay? Identify the common area, or what you call the feasible region. That would be the solution, or the feasible region. We call it FR, okay? Feasible region. So go back to the graph in the first example. I ask you to draw in the same graph. If you do draw the same graph, then you'll be able to identify the solution. Now, is there a solution? In other words, is there a common area? Is there the area? Is there an area that satisfies both inequalities? Or is there not? If there is not, then that means there is no solution. So let's look at the graph. Okay. Now, can we see a common area or there is no common area? Ada ke tak ada? Huh?
There is a common area.
Mana dia?
Ada.
Show me where is the area.
The left side.
The area on the left side.
Left.
Okay. The area is the intersection between the inequalities. So it's the area that satisfies both. So you'll see here, the 2x plus 3y less bigger than 27, less than 27. Less or equal to 27. Okay, the red area. This one, the red area. All right, the one that goes down. For 5x plus y bigger or equal to 24, that will be the area up there. So you will see the common area is the area bounded by that line only up to there, up to the intersection between the lines, and then bordering by that line. So that is our feasible region. Okay, call it FR, or common area. So label this. Okay, label this clearly. Now, one mistake that people do, they don't put the label. So label it, you know, label it big. I mean, not too big lah. At least correspond to the graph. Okay, so that we know what area we are talking about. All right. So that is the common area. Okay, any question? Okay, good. Now, second part. Okay, this is optional, but we need to know. If, okay, if I include the condition, the inequality that is given by the textbook, which is x bigger than 0, y bigger than 0. Let's say we include this thing. All right. Now, where is the solution? So go back to the graph. You have x bigger or equal to 0 as one constraint, and then y bigger or equal to 0 as another constraint. Where is the graph? I mean, where is the feasible region? Go back to the graph and locate.
No feasible region.
Okay.
Feasible region.
Huh? What did you say, Imran?
No feasible region.
There is no feasible region. Is that right? Because if you include that thing, the x bigger or equal to 0, all right, x bigger or equal to 0 will be that area. Okay. The y bigger or equal to 0 will be that area. Okay, will be that area. So as you can see here, will be the area. The only region or that area only intersect y bigger or equal to 0. Does not intersect with x bigger or equal to 0. So therefore, okay, therefore there is no solution. All right, because it does not satisfy all the inequalities. So if you look at, if I include this one, okay, if I include that one, what you will get will be no feasible region. In other words, no solution. Okay, because the common area does not satisfy. Okay, the common area, there is no area. Okay, there is no area that satisfy all. Okay, all inequalities. There is one area that satisfies 3 inequalities, which is y bigger or equal to 0. But it does not satisfy x bigger or equal to 0. So therefore, it is not solution, because our solution must satisfy all. So that's why, it's important that we know, or we correctly identify the region, okay, the area for each inequality, so that we can locate the feasible region correctly. Okay, all right. So, yeah, you know what? This thing is also good, x bigger or equal to 0, y bigger or equal to 0. So what I would like you to do, at least, you make your discretion, okay? It's up to you. At least for the questions that I give you here, at least a few, okay? A few you include, include this thing, so that it can be, it can be a good exercise. Because actually we are going to come up with the x bigger equal to 0, y bigger equal to 0 in application, okay, but not now. So to get a better understanding of, of these inequalities, so for the questions I give you, at least a few of them, one or two, you include that x bigger equal to 0 and y bigger equal to 0, so that you have practice on that thing. Okay. You understand what I say? All right, good. So do a few, okay? Do for if you include that thing. All right. So that is a system of inequalities. And you identify the feasible region. Okay, now let's do another example. So I have this graph here, 5x minus 2y bigger or equal to 104. Let's add another inequality to that one. Okay, 5x minus 2y bigger or equal to 104. So let me add another equation to that thing. Let's say we have okay, anybody can suggest me one inequality that can work out for this example? Okay, I'll give you another inequality. So we use this example already, okay, the graph, which you already have one inequality. We add one more. All right, so example number 2, I have a system. The first one, we already have the equation, the inequality, 5x minus 2y bigger or equal to 104. Okay, the other one, say you got 3x plus 7y bigger or equal to 70. Wait, I think I'm going to change this. Let's say 170. Oh, 170. So I would like you to find a solution. All right, find the solution or the feasible region to the system. So you need to do for the other inequality. We already did the first one. All right. Okay, you got the x-intercept for the second inequality. What is the x-intercept? Anybody got it?
56.67.
56.67. Okay, so that is the x-intercept. So you got the x-intercept as 56.67. Okay, so make sure you do the work, all right? How you got that thing? Okay, y-intercept, what do you get?
24.28.
24.6.
286.
24.6.
286.
I got 24.29. Or you can round out to 24.3. 24.3. So that is the y-intercept. Now you draw on the same graph. Okay, go back to the graph. You draw the graph. All right, and then see what we get. So what I will do, I will clear out all these things here so that we can include that new inequality. So that red line, I cannot do anything. So now, okay, I got all the points. All right, so there is no more broken line. We have that inequality. So you got the x-intercept 56.60. Oh no, 56.67. So what you do, just extend the points. So those 40 be somewhere here, 50 over there, here I got 60. So that is the x. So it's 56.67 be somewhere there. Okay, that is the x-intercept. Now the y-intercept is 0, 24.29. This is 40. So 24 will be somewhere here. 30 is in the middle. So 24 will be there. So the line, all right, for our second inequality would be that line. So connect it nicely, all right? So when you draw, make sure you draw with the proper graph. No, I'm sorry, proper interval. So I think oh, cantik. Okay. So this is 3x plus 7y equal to 170. So label the equation so that you know, okay, which equation is which line. So that is the purpose. So now you want bigger then. Okay, where is the inequality? Above the line or below the line?
Above the line.
Above.
Below, up or below?
Up.
Up.
Above.
Yeah, some people say up, people say below. So make sure everybody agree. So test one with 0, 0. Okay, you want bigger than here, bigger than 170. Above or below?
Above.
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 Yes.
Yes.
Below.
Test with 0, 0.
Below.
You know, you have to test with a point. Okay, the point I said is what? The simplest point is 0, 0. Test with 0, 0. Is it above or below? Those who say above, okay, do it with a test point, 0, 0. Okay, now, is it up or is it below? Cepat, huh?
Up.
Up. Are you sure? You know what I mean? Above. Above means here. Okay. Oh, I'm sorry. I was looking at the different. I was looking at the different line. I'm sorry. I was looking at the other graph. You're right. You're right. I was wrong because I was looking at the other graph. I was looking at the different graph. I was looking at this one. You know. So that is the line. Should be yeah. You are right. Should be up. Okay. Should be up because if you test with 0, 0, all right, that 0, 0 does not satisfy bigger than. It is less than. So therefore, the area will be the area up here. Okay, so let's say you do it with 0, 0. So I got 3 times 0 plus 7 times 0 equal to 0. And 0 is not bigger than 170. So 0, 0 does not satisfy. So therefore, the other side will satisfy. So the area that satisfies the inequality will be up there. So this is 3x plus 7y bigger or equal to 170. Okay, so is there a common area? As we can see, the common area is this area here. That is feasible region. Is the area bounded by that line up to that point, and after that bounded by the other line out there. Okay, all right. Now, if you look at the feasible region, what is the shape of that feasible region? You know, where is the end point of that feasible region? Go back to the graph. You know, you look at the visible region. How does the curve or the region look like? Or if I put it another way, what is the shape of that visible region? If you look at that area, you know that area is open area. Okay, it's open area on the right. So it will go infinitely far away, you know. So that kind of area, which you don't have a border, you call it open area. So the area is open area. Okay, the visible region for the system that we were talking about, that was open area. All right, because at least, okay, at least one side of the region or the area is not bounded. Okay, there is no boundary. You don't have boundary to close everything. So it is open, all right? You will see there is no definite shape. There is no definite shape. It is open, all right? No definite shape. So this is what you call open area, all right? Or sometimes they call it unbounded area. Now, if you look at the first example, that we got earlier, now that visible region, is it open or is it closed? This one.
Open.
Is it bounded on all sides or is it open on at least one side?
Open.
It's open. So again, you know, this one, you got open area, okay? The visible region is an open, there is no boundary, at least on one side. So just to demonstrate, you know, a closed area, what we'll do, okay, just to show a closed area, that means it has a definite shape and it satisfies all the inequalities. And you can see it has a proper shape, all right? So to demonstrate the closed area, what I will do, we will do this. We have another constraint. So this one, okay, this one I want to show a closed area, all right? So let's say I include x equal to 65. No, not equal to, because that's the equation. If I include x bigger or equal to 65 into the system, all right, then you will see you have a bounded area. In other words, the area, the visible region, has a proper shape. So put in the x bigger or equal to 65. And of course, you begin with x equal to 65. So x equal to 65. Is it a vertical line or is it horizontal line?
Vertical.
It's vertical at x equal to 65. So you got here 60. Okay, so 65, it will be somewhere here. Somewhere there. Because the interval is 10, so somewhere there. So that is 65. So the line x equal to 65 will be that line. All right. Of course, here is x equal to 0. So here x equal to 65. And did I say less than or bigger than?
Bigger than.
Salah bigger. Should be less than. Yeah, should be less than. So change that should be less than. Okay, so x is less than or equal to 65. So we go back to the graph. X less than 65. Where is it? To the left or to the right of x equal to 65? So
Left.
left hand.
Left.
Okay, less than left. So you got that this region here. Okay, so as you can see now, the feasible region is the area bounded by that line, and the vertical line x equal to 65. So for our second case, feasible region is bounded. So I just want to demonstrate, all right, the difference between unbounded and bounded, open, closed. So bounded or closed means it is bounded at all sides. So you have a proper shape. It can be rectangle, can be triangle, it can be, you know, shaped like hexagon. Okay, so it's a proper shape. So that is the difference between closed and open. So you have a closed area, closed feasible region. It is bounded at all sides. So you have a proper shape. Okay, so in this case here, it's like a triangle. So there are two types of area. One is the closed, the other is open. So that is about a system of inequalities. Okay, any question, anything? Good, all right. So now we are going to move on. I'm going to define a linear programming problem. Programming. Okay, a linear programming problem is this. You have an objective function. All right, you have an objective. And then you have some constraints. And you want to maximize or minimize that objective subject to the constraints. All right, so that is a linear programming problem. So here, the problem is we want to maximize or minimize an objective, okay, objective function. Sometimes it's not a function, just equation. But most of the time, we function, objective function, subject to some constraints. Or we call it a set of constraints. Okay. Now let's look at this definition more detail. So here you have an optimization problem. Okay, it's optimization because you want to maximize or minimize subject to certain limitation. Okay, so it's optimization. You have maximize. Let's say you have to maximize, but you face with what? With some constraint or limitations, or you want to minimize. So that is optimization. You want to optimize. You are not going to maximize. Absolutely. You're going to maximize subject to constraints. Okay, so that is our linear programming problem. Now, the objective function, this is one function. Okay, objective linear function. All right, the constraints, because here you have some constraint or set of constraints, this is a system of inequalities. So that means the constraints will consist of two or more inequalities. There is a system there. So what you want to do here is, given these constraints, the inequalities, you want to maximize, all right, or minimize the objective, which is presented by a linear function. So you have two things here, combination, okay? One is a function, which is linear, and that is the objective. The other are inequalities, which are the constraints. So you combine both, okay, objective and the constraints, you have an optimization problem. And that problem is called the linear programming problem, okay? Because it involves inequalities. So this is what we're going to do next. So we are going to do this next week, that will be our discussion. And again here, we are going only to focus on the graphical method. So that's why I said, this part of the chapter, this chapter is fairly short because we will do only one method, which is the graphical method. Don't worry about the other method. Yeah? All right. I think that will do it for today. Any question?
No.
Anything? Okay. If there is nothing, I hope you will do the questions. All right. Over the weekend. If you have problems, discuss with your friend, or you post a question in the WhatsApp group so that I can see. Maybe I can contribute, and your friend can also help. So do those questions so that next week, Monday, we can solve the linear programming problem. Because in order for us to solve the linear programming problem, you need to know what we learned today, okay? And what we learned earlier. So that's it for today. I'll see you again. Assalamualaikum warahmatullahi ta'ala wabarakatuh.
Waalaikumsalam.
Have a nice weekend. Take care.
Weekend.
Take care. Don't go out too much.
Thank you, sir.
Okay, thank you.
Thank you, sir.
All right, thanks.